Alright, so today we'll be talking about the actual quadratic functions and working with them. So we're still working with the standard form ax squared plus bx plus c. Okay, now here's some cool things. Alright, when a is not equal to 0, the parabola has an axis of symmetry. If you remember, we talked about it, but we didn't talk about how to find it. Now you know it. It was negative b divided by 2 times a. This is also the x-coordinate for the vertex. So, if I wrote out a formula, y equals 2x squared minus 5x plus 6, okay, and I asked you to find the axis of symmetry and the vertex of this shape. Okay, now obviously we would know what the y-intercept is going to be. So the y-intercept will actually be 6 because that's always the number at the end. It's the c. Okay, so right now we're going to use this formula to our advantage. So it's going to be negative b divided by 2a. Okay, so our b is actually already negative, so this is negative 5 divided by 2 times a, so it's 2 times 2, so 2 times 2. And this turns into 5 over 4. Okay, and now the axis is actually going to be x equals, so you need to put the x equals in there, okay? Something simple as that. Now the vertex, we already know what the x-coordinate is going to be. It's going to be 5/4. Pretty simple. But we do not know what is going to go in the y-coordinate. So what we need to do is we need to take this 5/4 and we need to plug it in for x and solve, because guess what? I have 2 letters. Now 2 are filled in and I only have 1 letter left, so I can actually solve it. Okay, so y equals 2 times parentheses 5 divided by 4, and then I'm going to square that, minus 5 times 5 divided by 4 plus 6. Okay. Alright, so if you have a fear of fractions, get over it now, because we're going to be going big time on this. So this is going to be 2 times 25/16. Alright, minus 5. Well, let's go ahead and multiply that out. So that would be minus 25/4. So that's my fraction already over there. Plus 6. Okay. Then this is going to become y equals, let me see. The 2 over 16 is going to reduce to 8, so that's going to be 25/8 minus 25/4 plus, and I'll just put this as 6 over 1, so that you can see we're going to have to get a common denominator. So y equals 25/8, right, minus 58 plus, and then, let me see, I need to multiply by 8, so that would be 48. So 48/8. Okay, and as you can see, they're all common denominators, all right? And 25 minus 50 is negative 25, plus that is 23. So y is equal to 23/8. So now I know what the y-coordinate is going to be. It's going to be 23/8. Voila! Not only do I have the axis of symmetry, which is x equals 5/4, but I also have the vertex, which makes my job a lot easier. And I also have the y-intercept of this actual graph. Okay? Alright, so here's the formula to find after t seconds. After t seconds, how high off the how high off the ground an object is. Okay. Right. Now, here's some cool things. Alright, so right here, this is going to be the speed due to gravity. Okay, so that's gravity right there. This is going to be initial velocity, and as you can see, this is c again, because this is going to be the actual initial height. This is going to be where, if we're dropping it off of something, this is where we're going to start. No, it's something nice that just works out this way. And if you notice, this is always going to be negative because we have this being negative in front. This a is negative, so this is definitely going to be an upside down type of parabola. Okay. Alright, so if we wanted to find out, let's say that we were shooting out of a cannon a person, and that person was being shot out at an initial speed of, let me see, 100 feet per second. Okay, and the cannon was 10 feet off the ground. This would be our formula that we would use. Okay, now to find the highest point that this, if I wanted to find the max height that this guy reached, okay, I would first need to find the vertex. So I know that taking a look at the actual form, okay, that this guy is going to be launched from an initial height of 10 feet. It's going to be like this. Now there is going to be a bunch of other stuff over here, and we'll talk about that when we go to Desmos in a little bit. But I do know that it starts at 10 feet. He gets shot up. I want to find this, because at the maximum height is going to be the distance right there. So I can't just find the distances between the two points of landing and then say, oh, that's, you know, that is that. I could graph it and just put it there, but let's say I don't have Desmos with me right away. Let's say I can't graph it. How do I find the max height? If I could find the vertex and I could find the x coordinate and then use that to find the y coordinate, I would be so set. Okay, so as you remember, the x coordinate can be found. It is the negative b divided by 2a, which in this case is going to be negative v, okay, divided by 2. It should be probably just a negative 32. Okay, all right. All right, and so what I'm going to do is do the 100 divided by 32. And if you're wondering why I'm dividing 100 by, or instead of negative 100, that's because negative 100 divided by negative 32 is the same as 100 divided by 32. Okay, and this is going to be 3.125. So that's how many seconds it took for this guy to reach that maximum height. Now, if I wanted to actually find out what that height would be, I would plug in 3.125 into my function and find it. So I'd go negative 16 times 3.125 squared, okay, and then plus 100 times 3.125 plus 10, okay, because I got to count for everything possible. So as I'm putting stuff in, make sure you're using your parentheses very carefully, and make sure you're squaring carefully too, and you're not accidentally putting a whole bunch of this problem into the actual exponent. Plus 10. And what we are going to get is the height when it's 3.125 seconds, or exactly halfway through the flight, is going to be 166.25 feet. Okay. 166.25. Now, when you are looking on Desmos, if you graph this and you just look for that, you need to understand that the context of this is going to be seconds, and this is going to be max height. Okay? Alright, now if I wanted to find how long this guy was in the air, I would just find when he landed. So I would find the x-coordinate, I would find the x-coordinate of when he landed, and we'll check that out in a sec. Alright, so if I take a look at this graph is going to be pretty funky. Now as you can see, this is right up here, and I can probably find that after 6.3 seconds, this guy's going to drop to the ground. Okay, but here's some really cool tricks to looking at this stuff. If you notice, everything's really large. If these numbers weren't as large, I would be able to see this. So if you change these and you divide these all by 10, so I'd put 1.6, I change this to 10, and I change this to 1. If I zoom in, I can see this a little bit better. Okay. Now, since I divided everything by 10, I would have to interpret the height as multiplied by 10. So just understand that. The time is unaffected, so that's kind of cool. All right, but as you can see, I can see this a little bit better and actually work with this, okay? So there's some really cool stuff that you can do with. Just realize this is on a scale of multiplying the y-axis by 10, okay? All right, the cool stuff is that you can graph this, you can actually see it. Now, here's the sucky part, is that a lot of people are going to think, oh, it's going to be from this time back here to this time here, so I need to add a 0.1 to it. No, do not ignore that one. Start here at 0, go up, go down to 6.35. Okay. Now, because we're starting at an initial height, okay, this is not going to be exactly halfway. So this is not exactly halfway in between. But if we did start at 0, let's make that 0, it would be exactly halfway in between. If you try to zoom in even closer, if you zoom in close enough, you can actually see 3.125 and then 6.25 right there. Okay? Alright, and that's it for working with quadratic functions. Hopefully you feel pretty confident with working with it to find the x-coordinate and the axis of symmetry. I'll talk to you later. Bye.